to another live office hour. We are here covering any GRE questions that you have. I'll just say if you are ever interested in taking our course, feel free to check our website. You can sign up for the live version of our course at testprepstudios.com or the pre-recorded self-paced version. All of that and more at testprepstudios.com. Well, we have two students with us here today, RH and S. So we will dive right into questions. Give me one moment to pull this up. Start with a question that RH sent, which is a good one, about circles and angles. So I'm going to pull this up. Share. There it is. All right, so we have this picture here. In the circle, line segments AD, BE, and CF all pass through center O. That's the center of the circle. And then we're given some, though not all, angle measures. So RH, let's start with this. Are there any other angles that you now know that you can figure out?
Angle O is also 95.
Right, based on our vertical angle or mirror rule.
Yeah.
You're right across from each other, so that's 95 degrees right there. What else?
And the angle across from 42 is also 42.
Right, so that's 42. Anything we can do to figure this one out?
Since the entire circle is 360,
Yeah.
you can add 95 and 42 times 2, I guess, each of them.
Oh, sure. And then divide by 2, right?
Yeah.
Absolutely. Or we could, I'll make it like a tad simpler. Half of a circle is 180 degrees, right?
Right. Mhm.
So if that's 180 degrees and 95 and 42 are already accounted for, what's missing?
Um, 43?
43 degrees,
Yes.
right? So that's 43 degrees. And then by our mirror rule, that also is 43 degrees.
Mhm.
So, sorry, let me just get rid of that. Boom, boom. Then the question is, what's greater, the area of shaded sector BOC, so this one right here, or the area of shaded sector AOF? I like this question because it tests kind of multiple things. Well, I'll throw it to you, RH. Any thoughts at this point, or is this as far as you got?
I got this far, and I think, like, pretty logically, AOF is
Mhm.
greater, but it's a quantitative comparison. So I was like, I don't know where to go from here to disprove that or try to break the problem.
Great. So fair enough. You can't, well, we can't break it because we can't test any other numbers, right? These numbers are locked in. Like this angle is 43 degrees and this is 42. So those aren't changing. But let's use some like logic and I'll make it a little more kind of like blatant. What's bigger? I'm going to draw two equal circles here. So these two circles are equal. Let's say I have an angle of 90 degrees and an angle of 3 degrees. Which one has a larger area?
90.
The 90, because I'm talking about a larger share of a pie,
Yeah.
right? So here, I mean, the naked eye can't see like that this one is which one is bigger, but this one has to be bigger because the inside angle is bigger. Since
Mhm.
43 degrees is bigger than 42, that means that this one has to be bigger.
Yeah.
Great. Great. Any follow-up questions on that from anyone? All right. And I want to make sure that no one's trying. Yeah, Vivian, for some reason, is having trouble. She had some trouble last week too. I'm just gonna quickly share some of the. All right. Okay, that should do it. All right, so let's move on to, we'll kind of bounce back and forth here. So I'll go to Sarah's question next. Ooh, Sarah, this looks good. Good old function question. Stop sharing that and start sharing this one. Okay. G is an integer and X is a prime number. Which of the following must be an integer? Interesting. So, there we go. I can tell this is Manhattan. So let's start with a test. S, can you give me a number for G and a number for X?
Number for G could be 2. And for X, 3.
3. Now, just as a more general footing, must be, when they give us that, when they say what must be an integer, we immediately want to think like a misbehaving child. Like how can I push the envelope? How can I bend the rule, or not bend the rules, break the rules? How can I make this not true? And that will allow me to eliminate it. But for starters, let's just to get our feet wet, let's just say G equals 2 and X equals 3. Okay, so 2 squared is 4. Times 3 is 6, right? Plus 5 times 6, that's 30, divided by 3. Sure enough, that's an integer. 30 divided by 3 is an integer. Okay. G squared 4 minus 9 over 3, that's also an integer. 6 times 1 is an integer, minus 100 times, what's G over 2? X isn't involved in this one, 1. That's also an integer. Okay, so with these numbers that we picked, they all work so far. Now let's get a little more, I don't know, let's think a little more about it. Like, it's fine to test numbers to start, but let's try to break this problem. And actually, I'm gonna do a little bit of algebra here. And S, you tell me if you're okay with this. I can break this up into G squared over X times X, right? Gx squared X over X plus 5gx over X. If I have a denominator on the bottom, I can break that up into 2 separate fractions.
Yes.
Right?
Mm-hmm.
So then that allows me to cancel, right? The x's cancel out and the x's cancel out. So I get G squared plus 5g is what this is. And I'm just going to rewrite that. When I can simplify and make my life a little easier, I want to do that. So that's G squared plus 5g. G is an integer. That's all I know about G. If I square an integer, S, will it never not be an integer?
No, it'll always be an integer.
Right. Whether the integer I'm using is 1, 0, a billion, 10,000, whatever. And if I multiply an integer by 5, it's always going to be an integer, right?
Mm-hmm.
And then if I add those 2 integers together, that's always going to be an integer. So this will always be an integer. First one is always going to be an integer. Again, G squared is always going to be an integer. So let's kind of leave that to the side. This is where things get interesting. Could you come up with a value for X? And remember, X is a prime number. Can you come up with a value for X where if I square it and divide by 3, it's not an integer.
If it's 2.
Sure, right? X is allowed to be 2. That's a prime number. 2
Yeah.
squared is 4, divided by 3, game over, right? That's a decimal, a non-integer. So that's out. Well, now let's look at this one. The only thing about G is that it has to be an integer. Could you come up with a number for G where G over 2 is not an integer?
One.
Sure, right? Let's try that. Because when G equals 1, I get 6 times 0.5 minus 100 times 0.5 squared, which gives me 3 minus 100 times 0.25. So 3 minus 25. Still an integer. Let's try simple. And I'll say this is a tough one. You can tell it's like taking a while to get through. Can we simplify our life a little bit more here? So like 6 times G over 2. Could I simplify this at all?
You could put 6 over. Could you put? I don't know. I was going to say 6 over 2.
Right. 6 over 2 times G, right? If I multiply these together, because that's what I'm doing here.
Right. Right. So it'd be 6 over. So it'd be 3 times G over 2.
Just 3G, because the 6 and the 2
Oh,
can't.
right. Yes.
Right. And then G over 2 squared is the same thing as G over 2 times G over 2. So that gives me 100 G squared over 4. What's 100 over 4?
25.
25. So what I have is 3G minus 25G squared. This is always going to be an integer. G is an integer. So if I multiply an integer by 3, it's still going to be an integer.
Yes.
And this is going to be an integer. An integer squared is an integer. Times 25 is still an integer. And if I'm adding, subtracting integers together, I'm always going to get integers. So this one is in as well.
That was very helpful. Thank you.
Yeah. And I realize it's a pretty involved explanation. I'd love it for it to be a little more straightforward, but best I can say is simplify those first and then test. Yeah. RH, back to you. And by the way, I don't know, Vivian, I don't know if you're watching on the live. I'm not seeing the messages from the live, right? I am, but I lost it. So feel free to send me email messages if you have any questions. So RH, we will bounce back to you in just a moment here. 1 second. There it is. Am I live streaming right now? I should be. All right. Well, whatever the case, I'll keep an eye on my email. Here comes the next question from RH. Triangle one. Yeah, this is a good one. Here we go. All right, so in the figure shown, what is the value of x? Everyone asks about this question. It's a very popular question to ask about. So RH, geometry has a lot of rules. Seat of your pants, what rule about triangles might come into play here?
30, 60, 90. One of them is a 30, 60, 90 triangle.
Yeah. So that's absolutely true and always worth clocking when we have a 30, 60, 90 triangle. Even more broadly, though, what do the angles in a triangle have to add up to?
180.
180. So I have two triangles here. I have this one that RH just noted, right? 30, 60, 90. I also have this one, right? Which has a 90-degree angle, a 40-degree angle, and then RH, what's the missing angle right there?
50-degree angle.
That has to be 50 degrees, right? So where's that? 50 degrees. There it is. So now let's keep playing with triangles. I have two other smaller triangles right here. I have this one, right?
Hmm.
That needs to add up to 180 degrees. So what's the missing piece?
130.
Yes. And if that's 130 and that's 30, then what's this one?
20.
20. This is a straight line. So what's the missing piece there?
160.
The,
Oh,
yep. That's a sneaky one.
yeah.
Excellent. I'm just going to keep an eye on the live stream. You might hear a reverb here for a second. Hmm. All right, well, I assume we're streaming. Okay. Next up, we'll bounce back over to S. And here's your next question. Ooh, another Manhattan one. Oh, yeah, I remember this one. Say that there's not a super elegant way to do this, aside from testing. So as a reminder for, and I know S and RH, both of you know this already, but for anyone watching who might not be as familiar with quant comparison, what they give you up here is like, is a given. It's a fact, right? It has to be true. So if we are going to test numbers, the numbers that we test have to fit this constraint. So S, could you give me a value of X and a value of Y that make this true?
Say X is 4, Y is 2.
X is 4, Y is 2 for starters, right? And we'll make sure that this works. 4 squared is greater than 2 squared, check. 4 is greater than negative absolute value of 2, also check. So these are acceptable numbers to test. And in this one particular case, 4 is greater than 2. As I always like to say, let's pat ourselves on the back and eliminate 2 answer options. S, which 2 can we now eliminate?
B and
Yep.
C.
Gone, right? And that's a nice feeling. Worst case, I'm down to a 50-50. Now let's try to break the problem. Well, the 2 numbers that we tested, just to kind of characterize them, were small positive integers. I'll throw it over to you, S. What do you want to try now, making sure that any number you do fits these constraints?
Negative numbers sound like a good idea.
Oh, sorry, could you repeat that?
I think negative numbers sound like a good idea.
Okay. Let's try.
Mm, negative 1.
X
And
negative 1.
yes, and y could be negative 50, I suppose.
That violates this first one here, right? Because negative 1 squared is not greater than negative 50.
Okay, so I'm trying to think of an extreme.
Sure.
I don't know. What do you think would be good numbers to test here?
We tested small positive numbers. Let's just tweak one thing about small positive integers. Let's just tweak one element of that. And I'll RH, if you want to hop in here and suggest an interesting number to test, feel free to.
Could we try -4 and -2? Just change
Sure.
the negative
Right?
aspect of it.
So we changed the negative aspect of it. We started with 4 and 2. Let's try -4 and -2 because -4 squared, 16, greater than -2 squared is 4. So check on that. Is negative, careful though, got a problem here, right? -4 is not greater than negative absolute value of -2, which is 2, right? So RH, what do you want to tweak? I think this was a good direction to move in, but what do you want to tweak now?
Um, what will change y?
Hmm?
You could do -1.
That's still a problem because -4 is not greater than -1.
It would have to be a bigger number.
Right. And I'll just note here, and this is productive, productive is like a concept in teaching called productive struggle, which is like it's good to kind of like hit up against a wall like this. The fact that we are struggling so much kind of tells us something. How about, well, okay, so we're having trouble with negatives, right? And the real issue is in absolute terms, if x squared is bigger than y squared, well, then that means that the absolute value of x has to be greater than the absolute value of y, right? Because if I'm squaring something, it becomes positive. It's effectively like absolute valuing it. So what about -4 and um, no, that still doesn't work. From what I'm seeing, I can't really make x a negative number. So how about +4 and -2? That could work, right? Then again, though, that doesn't really disprove what I did before because the numbers that that S tested were 4 and 2. X is greater than Y. The last one that I'll try here, and I'm at the point of kind of just throwing in the towel and saying quantity A is bigger. And we'll try to back this up with some logic in a minute, but the last sort of resort for me would be decimals, right? So like maybe X is negative 0.5 and Y is, oh, this might do it, negative 0.25. 0.5 squared is positive 0.25. Negative 0.25 squared, and feel free to use your calculator on this, is 0.0625. So that works. but this doesn't. Again, so through process of elimination or process of trying really hard with, to review, positives, negatives, decimals, I can't break this problem. And S, can you, I don't know if you have the answer in front of you. Can you just confirm that the answer is that the answer is A?
I will confirm. I don't have it on hand right now, but I'll pull it up. I'm sure.
Yeah,
I'm
I'm
sure you can.
99% sure it is. And the other, so the way to be like 100%, I may be able to articulate this, I may be able to not, is with a number line. Let's call, so x squared is greater than y squared. That could mean that x is here and y is here. That's one possibility. So they're both positive numbers, right? And x is greater than the absolute value of y. Well, that's true. Another option would be if x squared or x and y were like this. So like they're both integers, but x is positive and y is negative. Well, I should say that y is like a little less there, like that, right? In that case, this is true and x is still greater than y. I guess the way to come at it too would be to try if you can, I dare you, to make y greater than x. Anytime you try that, it doesn't work. Yeah, and S is confirming the answer is A. So I realize that's a long-winded explanation.
I
But
have something.
yeah, all
I
right.
don't know if this is so for the second, so x is greater than negative y, isn't it true that whenever you make an absolute value, ne oh wait, no, that's not true because if it's negative two, absolute value of negative two is two. Or
Right.
are there's always going to be two values for an absolute value, so does that make a difference at all?
Well, it creates more confusion because it means that multiple ones could be that we need to test both cases.
Okay.
But no, I mean, I'm doing this. Long story short, and this comes down to like, because we obviously wouldn't take however many minutes we're spending on this, like on the test. If you run through zone F, which we kind of did a little inefficiently, but we did, right? I suppose we didn't really test zero, but that is one possibility. If you run through zone F and you're still getting that A is greater than B, it probably is. I'll leave it at that.
We take the square root of both x and y squared to simplify it and just say we need to pick numbers that are within that fit the conditions of x is greater than y and x is greater than the absolute value of a negative y.
No, because if we just took the square root of this and it was x is greater than y, then we would have our answer. But the reason why we can't S is because the square root symbol means the positive square root. So for instance, let's pretend I told you that x squared equaled 9. What could x have equaled?
3
Or,
or -3.
right? I saw that the 9 came out of the box. I don't know what was inside the box, whether it started as a 3 or a -3. And so I can't like undo, I can't put Humpty Dumpty back together again, right?
Okay. Yes.
That's why I can't just kind of willy-nilly do that.
Mm-hmm.
But what I could, and I know we're dwelling on this, but it's bugging me a little bit. So like x is greater than absolute value of negative y. One thing I could do, I could multiply both sides of this equation by -1, right? Where x then becomes less than absolute value of y. And as a reminder, when I multiply both sides of an inequality by a negative, I flip the sign. Then I could break this up into its two possibilities, which is that y is greater than negative x, or y is less than x. It doesn't forget that. That doesn't help anything. It's really just testing here. And I'd be curious to know S, and we will move on here because I've spent it is my own fault. I've spent too long on this question because it's bugging me a little bit. But if the book has a better way, feel free to send that over because I am curious to know. Okay, Vivian sent in some questions, so let's take a look at one of hers. Yeah, let's just start with the first one. Oops, daisy. That. Share that. Oh, there's the explanation. Or they test by examples, right? Yeah. Yeah.
Yeah, even the way they explained it was bothersome to me, which is why I wanted to see you do it because it was just an annoying one.
Okay. So Vivian says, or was sent this question. This question has 5 answer choices. And this is an official one, if I recall. Yeah. Select all the answer choices that apply. The correct answer to a question of this type could consist of fuse. Oh, I see. Yeah, that's a really long-winded explanation for that. In triangle DEF, the measure of angle D, so I'm just gonna boom, DEF, definitely not drawn to scale, but it is what it is. I'm saying angle D is 25 degrees. The measure of angle E is greater than 90. So let's call that 90 plus. Which of the following could be the measure of angle F? And so again, Vivian, I apologize. I don't have the live feed in front of me. It's not coming up on it. Just try one thing. You may get a reverb here. Okay. Yeah. Okay. There we go. So Vivian, I can see the live stream chat. So you're welcome to type in there if you have questions. But let me pull this over here. Is that showing? Just want to make sure it's showing. Okay, whatever the case, let's keep it rolling here. So for this one, it comes down to the rule that we were doing with RH a little while ago, which is the sum of angles in a triangle has to be 180 degrees, right? And so when I say this is 90 plus, it could be 91, it could be 92, it could be 93, right? It could be 90.0001. Let's go back to what we were talking about in class about setting limits. We know that it can't be 90 degrees. But if we make it 90 degrees, that sort of sets a floor for that angle. And so 25 degrees plus 90 degrees is 115 degrees, which would mean that the missing angle would be, and I'll put this in red, the missing angle would be 65 degrees. Well, let's start upping this angle. Let's increase this angle. What happens as that angle goes up? Remember, 25 is locked in. 25 is not changing. But if that becomes 91, then this becomes 64. This becomes 92. This becomes 65. Excuse me, 63. This becomes 93, 62, and on and on and on. So it's a one-to-one sort of trade-off. The bigger this angle, you could also call it a zero-sum game. The bigger this angle gets, the smaller this angle gets. And the cap is 65, right? So it could be anything 65 and below. Any of those. Vivian, let me know if that makes sense, either in the chat or in my email. Okay, let's come back to RH. RH's next question was this. Ooh, another sequence. We'll see how this one goes, RH. All right, so let's share this. That. Okay, list A. Oh, that's nice. It's not in order, but whatever. List A, 20, 56, 27, 16, 24, 40, 37, 52. List B not shown consists of 8 numbers, all of which are different from one another. Each number in list B was obtained by dividing one of the numbers in list A by 4 and then adding 5 to resulting numbers. The range of the numbers in list B. Okay. So I'm going to quibble, and I know this is, I can tell this is an official question at RH, but I am going to quibble a little with it, unless this is what they're asking. Is the answer to this one D? And if it's not, then I have a problem with it.
Sorry, I'm checking. I'm on the
Oh, no
ETS
worries.
site now.
I'll like expound a little on what I mean. The instructions say take a number from list A, divide it by 4, and then add 5. But it doesn't say that it has to be a different number each time. Right? So like if I'm like if I'm
No,
very,
the right answer is B.
okay, so I have a problem with this question then.
Yeah.
Because, and maybe you did too. Maybe that's why you asked.
Yeah.
Your problem is the same one that I have, right? That like it never said, it said take one of the numbers in list A. It doesn't say take each number in list A.
Yeah. Yeah, I think that's where I had the issue. And so what I
Okay.
did was I took the range. So I took the greatest number in that set
Uh-huh.
minus um the smallest number and then divided that by the number of terms just because I was like, is that if that's what you guys are asking,
Hmm.
then it would I submitted A and that was wrong. And it's not D because I feel like we don't have enough information to figure out what list B would even consist of. So I had no idea where to go with this one.
Oh, wait a minute. Now that I'm looking at it, I may have jumped the gun. Maybe the ETS is smarter than I am after all. So let's go with my like how incensed I was. I was like, well, it could be anything. But let's actually start with what you said, right? We'll take the smallest one in this list and the largest one in this list. The 56. There we go. The algorithm, the instructions are take a number, one of the numbers in list A, divide it by 4, and then add 5. So for this one, what do I get when I divide 56 by 4 and then add 5?
19.
Yeah. Wait a minute. 56 divided by 4 is yes, 14 plus 5. Thank you. Yes. So 19. And then for this one, divide by 4 and add 5. What do I get?
9.
9. So what's the range?
10.
10. That's as big as I can make it, right?
Yeah.
I could make it smaller. I mean, if I just took 52 and did this 8 times, if I did that 8 times and just got the same set, then the range would be 0. But it will, they're totally right here. I'm wrong. It will always be less than 15 because the biggest I could make the range would be 10.
Okay, I see.
Right? Yeah, I was too smart for my own good. The ETS people are laughing. They're like, did you think a mere mortal like you could catch us in a mistake? Um, okay. Oh yeah, I just saw Vivian's email that. So let's go to S. I think this was the other one you had, S, right? Yep. Data analysis. Fun, fun, fun. Oh yeah. Didn't we do this last time?
Possible. You're probably right. I was thinking the same thing actually.
If so, it should be in the last office hours on the YouTube channel.
Yes.
So
Yeah.
feel free to watch. And if it doesn't make sense, let me know and we can go back through it for sure.
Okay. Yeah, I think there was just one part of it about the yeah, I would have to figure out exactly what my question was, but there was something about it that just didn't sit well with me.
Okay. Yeah, it's an annoying question. And I can tell it's Manhattan.
We can
But
come back to it. It's all
okay,
good.
yeah, let's circle back to that.
Sounds good.
Um, Vivian sent another one or another few here. So we did that one. And it was this one, right? Ooh, standard deviation. Yeah. So yeah, this goes to what we were talking about yesterday, Vivian, with standard deviation. The idea that you you have to understand the concept. You don't actually have to know how to calculate it. So the standard deviation of a set of 5 different integers, each of which is between 0 and 10, and the standard deviation of a set of 5 different integers, each of which is between 10 and 20. So between 0 and 10, it means strictly between, right? So there are not necessarily an infinite number of ways to do this, but many, many different combinations of this. It could be 1, 1, 1, and 1, and 1, right? 5 ones. It could be 1, 1, 1, 9. It could be 1, 1, 8, 9. 1, 1, 1, 8, 9. It could be 1, 2, 3, 7, 9. All of these different mixes would have a different standard deviation, as would all of these different ones. And yeah, sure, I guess it's higher up the line, right? 10 and 20 are like over here, but I could come up with just as many different ways to do this. I have no idea what the standard deviation is in here, and I have no idea what the standard deviation is in here. And if I'm nitpicking on this problem a little bit, and I were making this problem, what I would have done to psych people out is not say between 10 and 20, but say like between 10 and 25, right? Because I could have just had 12, 12, 12, 12, 12, 12, 12, so like a bunch of 12s here and a bunch of 6s here, and they would have the same standard deviation. Remember, standard deviation is kind of a measure of how diverse a set of numbers is. And just knowing the endpoints does not tell me how diverse it is within that set. So the answer here is D. And again, Vivian, just let me know if that makes sense. I'll keep my eye on the chat here and on my email. So RH, let's go back to you. Let's see here. Repeated sequences. Ooh, this is one of my favorite ones. This is the circle, 2 circles, the tangent circles. Okay. So here's that. So RH, we have a big circle and 2 tangent circles. 3 circles with their centers on line segment PQ. So that tells us this is like a diameter, right? Our tangent, that means touching right there at points P, R, and Q, where point R lies on the segment PQ. We want to know what's greater, the circumference of the largest circle or the circumference of the 2 smaller circles. I'll start with this. They don't give us any values. And therefore, implicitly, what they're saying is the scale here doesn't matter. We could be talking about a circle that's 1 billion miles in diameter or 1 inch in diameter. We could scale this picture up or down. So for starters, just as a test, right? I'm not committing us to anything here. But RH, could you provide a length of the diameter that PQ could be?
10.
Sure, why not? We're just going to say that this diameter is 10. And again, just as a test, could you give me the individual diameters of PR and RQ?
5 and 5.
Yes. Nothing is stopping them from being equal to each other. I realize the one on the left looks a little bigger than the one on the right, but there's nothing stopping them from being equal because the figures aren't drawn to scale necessarily. We have to assume that they're touching. We have to assume that R is on these points because it tells us all these things. But otherwise, we can set them equal to each other. Okay. So RH, if 5 is the diameter of this circle, what's the circumference
Of PR,
of PR? Yeah.
the circumference is 2 pi r, so 10 pi.
Ooh, the diameter is 5.
Oh, is the circumference the diameter pi?
The circumference
I
is
don't remember the circumference formula.
circumference. So circumference is 2 pi r. You can remember it that way,
Oh,
or
2 pi r.
because 2r is the diameter, right? So as a shortcut,
Oh,
we
so
can
it's just 10d, 10 d, 10 pi.
for PQ,
For,
10 pi. Or you're talking about PR,
I'm
right?
talking about PR.
Well, if the diameter is 5, then the circumference is what?
5 pi.
5 pi, right? And I mean,
Yeah.
I could break it down into,
Sorry.
oh, no, totally fine. If the diameter is 5, then the radius is 2.5. And then I guess you could say 2 pi times 2.5, and that gives us 5 pi. But the circumference of the left circle is 5 pi. What's the circumference of the right circle?
5 pi as well.
And what's the circumference of the big circle?
10 pi.
So the circumference of the big circle is 10 pi. That's quantity A. The sum of the circumferences is 10 pi. Okay, I just found a case where they're equal. Which answer options can I now eliminate?
A and B.
A and B are gone, right? My goal now, as always, is to try to break the problem. Now, we tested a case where the diameters were equal. So maybe we just got lucky. Can you give me a case now where the diameters aren't equal, or can you give me numbers for PQ, PR, and RQ?
PQ, we can make it like 100.
Sure. Go big, right?
And then PR, like 1
Okay. Yeah.
and 99.
99. And I love these numbers because they're like pretty far out there, and yet there's nothing stopping them from being the case, right? What's the circumference of P? And I can tell you already see where this is going.
Yeah.
Already. What's the circumference of this circle?
1 pi, so pi.
Right? And then this one over here,
99 pi.
so add them together,
100 pi.
right? Which
Yeah.
is, yep. And then by this point, like with that example, we're like, this is done. It's always going to be equal because of this relationship. The sum
Yeah.
of these equals the diameter of that. Yep.
Okay, I see. Thank you.
Yeah. Vivian, back over to you. I'll keep an eye on the chat as always. Here it is. Okay. Vivian, right back over to you here. Oh, the power station one. Yeah. Love this one. Power station is located on the boundary of a square region that measures 10 miles on each side. So let's draw that. There's my square. Square region, 10 miles on each side, 10 by 10. Okay. 3 substations are located inside the square region. That's pretty vague, right? The 3 substations could be here, here, and here. They could be here, here, and here. They could be here, 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 right? Like they could be anywhere as long as they are inside the substation. We want to know what's greater. The sum of the distances from the power station, the main power station, to each of the substation, or 30 miles. And oh, it says the substation is located on the boundary of the square. So it's somewhere on this square. Let's just put it right there for the time being, right? I'm going to put the big power station right there on the corner. Doesn't have to be, but I'm going to put it right there. This is a case of finding I'll be fancy and pluralize this, minima and maxima, right? Minimums and maximums. There's no minimum to how small this is. If I put the power plant, the substation's like right next to it, I could very easily make this the sum of the 3 distances. So just like to be exact, put them there, there, and there. Boom, boom, boom. The sum of those 3 distances being 0.1 miles away, easily I could make smaller than 30 miles. So right off the bat, I know that A and C are out, right? I can very easily, with the constraints they've given me, make quantity A bigger. Or sorry, quantity B bigger. The real question is, can I make quantity A bigger? Can I make the sum of the distances of the 3 power stations greater than 30 miles or equal to 30 miles? Well, how would I go about doing that visually? And I'll color code this. I want to try to get the substations as far away from the mother station as possible. And that would be, call it like right up to that point, right? And for the sake of like rounding, let's just make it all the way across the circle, right? Like a millimeter inside the boundary. Let's put all 3 of them right there. Well, what is that distance? Remember, I'm dealing with a 10 by 10 square. So if I know my special right triangles, it is a square, right? That's going to be 10 root 2. And if all 3 power stations are that far away, or like just a hair below that far away, that's going to be 10 root 2 times 3, which is greater than 30, right? Because I know 10 times 3 is greater than 30, so 10 root 2. Let's do an exact number here. I think it's like 14 point something, right? Because the square root of 2 is 1.41. Times 10. So 14.14. Right? If each power station is 14.14 away, then the sum of the 3 is going to be greater than that. And I have found a case disproving the first one. So again, like that slope question we were doing in class, where it like the slope question we were doing in class, where it's helpful to like minimize and maximize, because sometimes doing that is all you need. Okay. Okay. And Vivian, let me know if you have any follow-ups on that. But let me jump back to RH. I think this is the last one we have time for. Maybe able to squeeze in 2. Let's see. Exponents. Oh, this is a good one. I always say that, don't I? It's either like, this is a good one, or like, not this one. There's nothing in between. I'm never like, this is an average question. This is like just your run-of-the-mill question. All right. K is an integer for which 1 over 2 to the power of 1 minus k is less than 1 over 8. Since this is a given, right? Since this is our sort of like information that must be true, let's try to pick a value of k that could work for it. And 1 is not a bad number to start with. Like, let's just start with 1. What happens if I plug in 1 for k? I get 1 over 2 to the power of 1 minus 1, 2 to the power of 0. So that's 1 over 1, which fails this, right? So like that doesn't work. What if I make it 1 over, I make k equal to 2. So that's 1 over 2 to the negative 1. Is that less than 1 over 8? Well, 1 over 2 to the negative 1 is 2 to the 1, right? Negative exponent. Well, that's not true. So I'm clearly going in the wrong direction here. Let me start using negative numbers. And RH, please slow me down if this logic isn't quite computing. But what if I made k equal to negative 1? What would I get there? I would get 1 over 2 to the power of 1 minus negative 1. So 1 plus 1, so 2 to the power of 2. Still doesn't work, but at least now I'm going in the right direction. Right, 1 over 4. What if I do 1 over 2 to the power of 1 minus negative 2? So I make k equal to negative 2. Well, then they're equal. Still not true, but like I'm right on the cusp now. Like I'm on the verge of making this work. The integer, because I can only test integers here, that's going to make this work is k equals negative 3 and beyond, right? Because if k equals negative 3, the game that, and RH, let me know if this makes sense. The game that I'm kind of picking up here is when I subtract a negative number, I'm adding it. And I want the denominator of this left fraction to be bigger than 8. That's how I'm going to make the whole fraction less than 1/8. And there was a helpful little hint that they gave us up front. They said, hey, what's bigger, k or negative 2? You always want to ask yourself, what's the significance of this number that they're offering in quantity B? What's so special about negative 2? So if I'm rewinding and going back to the beginning, I might say, maybe I start with negative 2. Because if I start with negative 2 and it doesn't work, well, at the very least, I know that answer option C is out, right? If I test a number that they gave me, like against quantity A and quantity B, and it doesn't work, that means that C fails, so they're not equal. The correct answer here is that K has to be a number less than negative 2, so more negative than negative 2, which means that quantity B is greater. Is that all right, RH?
Yeah, that makes sense.
Okay, I got to run for now. I will have another office hour soon. I'm going to stop the live stream. Thank you, everyone who's watching there on the live stream. Where's the streaming? I don't know how to stop the streaming. Oh, no, I should probably stop sharing.